Hi, this is Arivarsan. Today I'd like to explain about the computational algorithm project. Here we have implemented a secure messaging application using a post-quantum cryptography. My teammates are Shiva Marni, Rushi Kiran, and Jivan Reddy. The secure messaging application using post-quantum cryptography is a type of message application that uses encryption techniques that are resistant to attacks by quantum computers. This is important because quantum computers are expected to become powerful enough to break many of the currently used cryptographic systems. In introduction, traditional cryptographic algorithms such as RSA and AES are vulnerable to attacks from quantum computers. This poses a significant threat to security of communication systems that rely on these algorithms. Post-quantum cryptography or refers to cryptographic algorithms that are believed to be secure against attacks from both classical and quantum computers. These algorithms typically use mathematical problems that are believed to be hard for quantum computers to solve. The development of secure communication system using this post-quantum cryptography involves choosing appropriate algorithms for key generation, encryption, and the signature. In this case, the XMSS signature scheme is used for signing the messages, and the Frodo key encapsulation mechanism is used for key exchange. Um, Here the XMSS is a hash-based digital signature scheme that is believed to secure against quantum attacks, and the Frodocom is a key encapsulation that is also believed to secure against quantum attacks. The secure communication system developed using these um, uh, post-quantum cryptography algorithms provides a robust and a reliable way to send messages that is resistant to attack from quantum computers. Here are the problem statement. Here in this project aim is to develop a secure messaging system using the post-quantum cryptography to address the secure concerns of digital communications in the age of quantum computing. The proposed system employs the XMSS signature technique and the Frodom key encapsulation method to ensure the message security between users. With a increase of use, with the increasing of use of quantum computing, the need for secure communication techniques that can withstand such attacks is becoming more critical. Therefore, the development of a post-quantum cryptographic messaging system is a significant step towards ensuring secure digital communication in the future. While coming to the motivation, this project aims to develop uh, a secure messaging platform that can withstand um, attacks from quantum computers by using the post-quantum cryptographic algorithms. The platform is designed to provide a viable solution to the issues of secure communication in the quantum era while processing post-quantum cryptography. The goal is to create an application that is immune to potential quantum computing risk in the future and offers a secure means of communication for a few users. These are the discoveries and the important milestones which we faced in this project. During the development of the secure messaging application, the importance of the choosing appropriate post-quantum cryptography algorithm for different use case was discovered. It was found that different algorithms perform different depending on that specific need of the application. Additionally, the application or architecture must be carefully planned to effectively and appropriately deploy a post-quantum cryptographic techniques. And meanwhile, the development of private messaging application involved several significant milestones. The first was the selection of appropriate algorithms through extensive research and the testing. The second milestone was that successful Python implementation and thorough testing of the Frodo key encapsulation technique, and as well as the XMSS signature scheme. Finally, the secure messaging application architecture was designed to make use of the post-quantum cryptographic methods, providing the secure communication between the users. Now, coming to the coding part, here I have discussed with my team members for that upcoming, algorithms which we are going to use, and that techniques and signature schemas which we are using. For that dependencies, everything I have imported at the starting of this code. Um, Here at starting, we have imported that necessary libraries like a socket for creating the network socket, the threading for creating threads to send and receive messages simultaneously, and crypto came Frodo New Hope, which I have created for a key exchange, and a public key, which for a public key encryption, and a digital signature for DSS, and I have included the AES for asymmetric key encryption, and the crypto hash for generating the hash values. And after that, here we are prompting the the text which we used which will ask that user to enter the values of one or two, which means if the user is going to be a host, they have to select the one, and if a user going to be a client, they have to select the value two. After asking the user choice, the code asks the user if they want to host or connect to the chat. After that, generating an XMS key pair. The code generates a new XMS key pair. XMS is post quantum public key cryptographic system that is secure against attacks from quantum computers. If a user selects to host a chat, the code setups a server socket, bind it to localhost on port 9999, and listen for the incoming connections. In XMS's key pair, the SHA-256 as function is used in this code to create a new XMSS key pair with a tree height of 20. Then after giving in the message, the signature under the public key, we sign a message using the XMSS object sign, and verify that signature using the verify method. Here, by saying that, we can see the choices code. If the user select as the one, uh, we will go here. Then this it will host a chat. Here are the socket connections you can see here, and here I have select entered the local host as default. If it is not work, we can replace with that system IP number by getting the IP address from a CMD. And here we can see the server listen. Of course, if I user select the option one, it will host as a listening for a communication.
Hi, my name is Shiva. Today I'm going to explain my contribution to the project for the secure message application using post-quantum cryptography is when a client connects, the server sends its public key to the client, and the server then generates a new product key pair using its private key and then client's public key to it generates a shared secret key. So connected to chart, if the user selects to connect to the chart, the code creates a client socket and connects to the server on the port 409. The client then sends its public key to the server. The client then generates a new product key pair, uses its private key and the server public key to generate a shared secret. So coming to the code, so from this line, this code waits. This code waits until a client connect to the server and accept the connection, and it returns a tuple with the two values. the client socket object, and the address of the client. So uh, this code sends the public key to the other parties, either the clients or the servers. So coming to this line, uh, it generates of a new product key pair. Actually sends the public to the client. This is the encryption. The client need to the public key so that it can client can message back to the servers. It will use the public key to encrypt the uh, chat messages. So coming to the shared secret using the private key and the public key received from the other parties. Shared is a function is the method used by the parties who sends the key first. In this case, the hosting the client. So coming to in second choice, it will sends public key to server side again, and there is a simple exchange of public key. So coming to this client socket, this code creates a new client socket object which will be used to connect to the server, and we can see the client code. It has the function uh, server public key equal to client dot receive 2048. So from client side, from client side, its server needs to communicate with the client. Then what client is going to do is the client is also generate two pair of public key and private key so that it can exchange with the server again. Because it's a tool for communication, we have also enabled the client side is generates a public key pair. So coming to this shared secret line is the private key in the client public key to create that entire shared secret messages. So for the in the else conditions exit method, this code exit the program if the users enters an invalid chart. Thank you.
So, hi, this is Jivan. So, now my contribution for the project secure messaging application using the post quantum cryptography is sending messages. So to define sending messages and receiving functions, the code defines two functions, that is sending underscore messages and receiving messages. So these functions run in separate threads and handle the sending and receiving messages between the parties. So these sending messages, the sending messages functions prompts the user to input message. So it creates a digital signature for the message using the XMSS private key. Then encrypts the message using the AES encryption and the shared secret, and sends the encrypted message and tag to the receiver. Now going to the uh, uh, code. So this is defined sending messages. So define sending messages is, so now the function starts by using an input loop to keep them to keep accepting the message from the user. Then it creates a signature for the message in the form of hash function. That is hash function is equal to lambda x SHA 256. So in this, the message that the user entered is then signed using the digital signature standard, that is DSS, and XMSS key pair generated earlier. So the signing process involves creating a high um, I of the message using the SHA 256. So, and then the encrypted hash with the XMSS private key. So, in this, if you in the sending message, if you try to send a code using from to any other, then we'll get the public code of the receivers. So, and then you will encrypt the code which we want to send. So then In the next step, we encrypt the message using the AES. So in this, in this, so this is the encrypt the message using the EAS. So in this, the message is then encrypted using the shared secret generated earlier and then advanced encryption standard. So cipher in AEX mode. So then the encrypt and digest function is used to generate the cipher text and then and auto authentication text. So in the last step, we will send the encrypted message tag and tag to the receiver. So in this, the encrypted message and the tag are then sent to the receiver over the network using the socket concession. So in the last, we print the message. So finally, the original message that was entered by the user is printed to the console for the confirmation. Thank you.
Hi, this is Rishikiran. I just implemented receiving messages in secure messaging application using post-quantum cryptography. Receiving messages. The receiving message function receives the encrypted message and tag from sender, decrypts the message using AES encryption and shares the secret and verifies the digital signature using the XMSS public key. Running threads. Finally, the code creates two threads, one for sending messages and one for receiving messages. And then it starts from them running simultaneously. And I will show the code here, receiving messages. In these receiving messages, that receives encrypted messages and decrypt them using AES encryption and verifies the digital signatures using the XMSS algorithm. In this code, the function receives messages from a client socket object passed as a parameter and continuously loops to receive messages. It first It first receives the encrypted message and tag from the client, and then uh, it decrypts from the received encrypted message and tag from the client, and then it decrypts the message using the shared secret key, and then it verifies the message digital signature using the XMSS key. If the signature verification is successful, the message is printed to the console. Otherwise, an error message is displayed. The code then starts two threads for sending and receiving messages from the server. The function is a part of large program that allows secure communication between two parties using AES encryption and XMSS digital signature. This is the code part which we have created here. And uh, then I like to show the demo of the secure message application. Give me a second. Here, I would like to show the demo of the secure message application. I am just executing the Python file in the command prompt, just entering the file name here. You can see that here. We created our file name as a post quantum. See, it is showing like, would you like to make this terminal to host one or connect to enter your choice? Yeah, okay. I would like to give the same here as well. Sorry, it's just an error. We just entered the file name here in these two command prompt. The left side is the host and right side, it is connecting to the host. So I'll just give one here and do enter. And here I can give the host two. So I just give a message from the client side. I just say hi. You can see here, it is showing your partner message hi. This is the secure message application we implemented by using post-quantum cryptography. Thank you.